Good day once again, students. We are going to continue with our photosynthesis. Don't be bored. Don't think, oh, it's taking a whole lifetime. It is worth the time. Photosynthesis is worth the time. It is worth giving it some time because it is very important in your life, in my life, and in the life of every human on earth, every living thing on earth, as a matter of fact. Now, we want to investigate photosynthesis today. Why are we investigating photosynthesis? As scientists, you need to investigate so that you can improve upon life. We can improve upon our life. New things can come out from the result of our investigation. So the first thing we want to investigate today is the proof or the evidence for photosynthesis. How are we sure that photosynthesis is taking place in green plants? How are you sure and how am I sure? One thing we know for sure is that glucose is produced during photosynthesis. Glucose is produced during photosynthesis. Whenever this glucose is produced, glucose is a soluble substance. If you go to the pharmacy shop now, or you go to a grocery or shop, any shop, and say, please, I need a can of glucose. Pour the glucose in some water, it will dissolve. So glucose is highly soluble in water. Because it is highly soluble in water, immediately it is produced in the leaf. It is stored because it is produced during the day. So it is quickly stored in the leaf. And the storage form of it, that is, it is stored in form of a particular type of carbohydrate known as starch. So glucose quickly gets converted to starch, which is a polysaccharide. If you don't know about polysaccharide, you know more about polysaccharide later. Monosaccharide, glucose is a monosaccharide, while glucose is a monosaccharide, while starch is a polysaccharide. So whenever glucose is made in the leaf in the afternoon or during the day or in the presence of light, it is immediately converted to starch for storage. It is immediately converted to starch for storage in the leaf. Right there in the leaf, it is converted to starch, and that starch is present in the leaf there. Immediately the glucose is formed, it is quickly converted to starch, which is a storage form of carbohydrate. Glucose is a carbohydrate and starch is a carbohydrate, so it quickly gets converted to starch as it is formed. Now, later, when there is no light at night, glucose is needed for the plant, by the plants, in all parts of the plant. Glucose is needed for respiration, which, if you don't know, you're going to talk about it soon. For respiration to occur, we need glucose. So this glucose must migrate to other parts of the plant where they are needed. But the starch cannot dissolve in water, and the movement medium in water is in plant is water. You have to be dissolved in water to be carried to where you are needed. So what happens at night? Glucose again reverses, starch again reverses and gets converted to what again? Glucose. Again, in the afternoon or in the presence of light, immediately glucose is formed. It is stored as starch in the leaf, right there in the leaf. That means during the day, if you pluck the leaf of any green plant, the green leaf, you can test for starch. There will be starch there, present in there. At night though, this starch again reconverts back to glucose, and it dissolves in water, and the water takes it to other parts of the plant below, in the stem, in the roots, where they are needed, where the glucose is needed for respiration. That process is another process known as translocation. The glucose is not translocated. We are going to talk about that soon. Now that you have known this, that means for you to show that photosynthesis occurs in the leaf there in the afternoon, to show that photosynthesis actually occurs, we can use the presence of glucose in the afternoon or in light as an evidence that photosynthesis actually occurs. So once a leaf contains starch, if we can prove that there is starch in a particular leaf, that means that leaf has gone through photosynthesis and glucose has been produced in that leaf, and that glucose has been converted immediately to starch for storage during the day. That is why the starch is there in the leaf. So our evidence for photosynthesis in every leaf is the presence of starch. Our evidence that photosynthesis has taken place in every leaf is the presence of starch, because that starch, yes, not the product of photosynthesis directly, but the glucose which was formed immediately gets converted to the starch. So when starch is present, glucose has been was formed. When glucose is present, photosynthesis has occurred. So we're looking out for starch in leaf. That is the evidence for photosynthesis. So our first investigation is evidence. We want to investigate, want to show, want to look at an experiment to show that photosynthesis has occurred. And we are saying that the pointer, we are saying that indicator, we are saying that the thing that tells us, that shows that photosynthesis has taken place in any plant is the presence of starch in the leaf of that plant. So how do we test for the presence of starch in the leaf of a plant? That is the first thing we are going to look at. Testing. So this is an experiment. Experiment to test for the presence of what? Starch. Write it down. Experiment to test for the presence of starch. Experiment to test for the presence of starch in leaf. This is the common experiment. Starch is present. Experiment to show that, or the presence of starch in a leaf. That is the experiment we are looking at first. Now, we have many of your books will take this one to be stage 1. Yes, you are correct. But I am going to take it to be stage 2. My stage 1 is that get 2 leaves. One of the leaf, you are using it as for the experiment, and the other one for control. For control, to choke, to check. Now, get 2 leaves. One of them, green leaves, one of them a discharged leaf, and the other one the leaf from a photosynthetic plant. A discharged leaf means leaf that the starch has gone. You have removed the starch. That means leaf just coming out from darkness. If you have at night, the starch from the leaf gets converted to glucose and used up by the plant, so that means at night the leaf is getting depleted of starch. The starch in the leaf is getting removed. So at dawn, very early in the morning before sunrise, before the sun comes out, you quickly pluck a leaf. There is a very big chance that in that leaf there will be no starch, of course, because all throughout the night the starch has gone. So that's why you call it a discharged leaf. A leaf whose starch has been depleted, whose starch has gone, whose starch has been taken away. So that is a discharged leaf. Not detached, discharged. 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 Starch is no longer there. Discharged leaf. A leaf without starch. So that is a discharged leaf. Or you have a potted plant, kept it in a dark cupboard. A dark cupboard. For hours, with 6 hours, 7 hours, that plant assumes it's at night because there is no light. So the leaf from such plant is also discharged. The starch is also gone. So 2 leaves, one from a plant in the what? In the sun, maybe a potted plant in sun, and the other one from a potted plant kept in a dark cupboard for hours, or one from a plant when the sun is about to, before the rising of the sun in the morning, you pluck the leaf from the plant, and later in the afternoon, maybe by 12 p.m. after the photosynthesis must have occurred in the plant, pluck another leaf from same plant. So and take the 2 leaves. I have the 2 leaves here. So that's my own step 1. Step 2 now, take the leaf first. 2 of them, you have this setup, 2 setup like this. First, step 2, which some books call step 1, boil the leaf. Let me show you step 1. You write for step 1 first. Step 1, pluck 2 leaves, one from a green plant which has been exposed to sunlight for few hours, and the other from a discharged plant. Green plant before sunrise. Write this one down. That's your step 1. Step 2 now, boil the leaf in water for about 30 seconds to kill them. You want to kill the leaf, or to, some books will say to kill the cytoplasm, or to kill the protoplasm, or to soften the leaf. So we just say boil in water for 30 seconds to kill them. Put it in boiling water for 30 seconds, heat for 30 seconds to kill them. That is step 2, and I want you to write it down. Boil leaves in water for about 30 seconds to kill them. Immediately after that, take the boiled leaf. Don't forget, whatever is happening to this is also happening to this. This is, you label them. This is leaf from the photosynthetic plant from the sun, and this is the leaf from the dark cupboard. Whatever you are doing to this, you are also doing to that. Dip this in alcohol. This is alcohol. Alcohol. Dip the leaf in alcohol and place the alcohol in the water bath. So, and boil again in the boiling water. So boil it there in the water bath. That is alcohol. That's water bath. Because alcohol is what? Is volatile. So, and that's alcohol. What are you doing that for? You are trying to decolorize the leaf. Decolorize, or you are trying to remove the chlorophyll. You are removing the chlorophyll from the leaf. So that makes the chlorophyll in the leaf go. So that makes the chlorophyll in the leaf go, and write it down. Step 3. Dip boiled leaf. The boiled leaf, the leaf you have boiled before, in hot alcohol on water bath to decolorize them, or to remove the chlorophyll, or to remove the chlorophyll. Their chlorophyll. Don't forget, you are doing 2 leaves at the same time. One is for control, to remove their chlorophyll. So that's step 3. So now this leaf now is decolorized. It's decolorized. It has no color of its own. It has no color of its own now. Decolorized. That leaf is a decolorized leaf. It's a decolorized leaf. Same thing happens to this. It's discolorized because you are doing both of them at the same time. Both of them at the same time. So I'm not saying it to be gray. Let's just say it appears like that. It's decolorized. It's a decolorized leaf. 2 decolorized leaves like that, because you are doing the same thing to them. But you label them. This one is from a photosynthetic plant outside, and this is from the one without without photosynthesis, with photosynthesis, without photosynthesis. Make sure you label them. Now the next thing is quickly dip your leaves again in water. Dip the leaf in water. That's the next step. The next step, you dip it in water, place the colorized leaf in hot water to soften them again, because when you put it in alcohol, it may be hard again. So you quickly put it in water again to soften the leaf, again. So now you have softened the leaf again. You soften the leaf first to kill the leaf or the cytoplasm. Then you dip in alcohol, hot alcohol that is placed in water bath. So then you remove the leaf when it is decolorized, and you place the leaf in another hot water to soften them again. Then the last step is a step where you want to test. It's a step where you are testing. So you place the leaf again in water bath, again in hot water again to soften them. Then you now lie the leaf on a tile. This is a tile, white tile. Place the leaf on a white tile and add iodine solution. Add iodine solution. This is iodine solution. You open your iodine bottle, take some with the dropping pipette, and you have your iodine there. And now come here and drop this iodine on your leaf. Drop the iodine on your leaf. What will you see? Dropping the iodine on your leaf, what will you see? You will see that the color of the leaf, the leaf that is photosynthetic will change to blue-black. That leaf will become blue-black. That leaf will change to blue-black. Why is it changing to blue-black? Because when starch is present and you allow iodine to react to starch, you will change the starch to blue-black. So you can see any starch dropping, any alcohol, this thing dropping by the side, iodine dropping by the side, we have iodine color. Any spill of iodine by the side will still have iodine color, but my leaf is having blue-black color. You can see what we are saying. So that leaf is blue-black in color, but the other leaf, I clean it again. I have my leaf with blue-black color. I have that leaf with blue-black color. It shows glucose is present. It shows glucose is present in my leaf. Starch is present in my leaf. If starch is present in my leaf, that means it has undergone. It went through photosynthesis. I passed through the process of photosynthesis, produced glucose, and that glucose got converted to starch stored in the leaf. So that's why the leaf I pluck from outside, from the sun, from photosynthetic plant, this will occur. But the other leaf which I plucked from the dark cupboard, when I had my iodine solution, of course the color will be the color of iodine, because there is no starch in it. There is no starch. You can see that leaf, there is no starch in it. That leaf has no starch. It maintains the iodine color. So when you place them side by side, you see that this one has glucose and photosynthesis occurs here. The other one, which is a control, no photosynthesis. So this is how to test for starch, and that is my step, the last step. So you say step 5, test leaves with iodine solution. Leaves from the starch plant. Leaf takes the iodine color, starch absent, because there was no photosynthesis. Leaf from the plant in the sun, leaf turns blue-black, starch present. That means photosynthesis took place. So whenever we want to check whether photosynthesis took place in any plant, what we are going to test for is the presence of starch by passing through this method I have just shown you. First, you discharge you get two plants, two leaves, one from a photosynthetic plant outside in the sun, that has been in the sun, and one from darkness, or just early in the morning when there was no sun, or from a dark cupboard. Then you pluck it and you test for starch using the method we have stated for you. If you don't understand, you can rewind to get every bit of it and write your note. Now that we have evidence for photosynthesis, let's continue with more investigation. How do you show that oxygen is released during photosynthesis? How do you show that oxygen is released during photosynthesis? That oxygen is released. Now I have a potted plant, an aquatic plant, Elodea. This Elodea is an aquatic plant. It's very popular. It's very popularly used for this experiment. I place it inside water, and of course I feed it everywhere like that. There is no space on top there. And I place it in the sun, or I provided artificial light. That's my sunlight there. That means photosynthesis. This is the beginning of the experiment. You can see there is no gap here, no space here on top of my test tube. As time goes on, I find out that later I see gas collected here. How do I know gas is collected here? The water level drops, and of course there is gas here. So if I now I know that gas has been collected there because water level has dropped inside the test tube. So what do I do? How am I sure that it is oxygen that is collected there? As chemistry students, this will be easy for you. For those of you who are not chemistry students, there is what we call test for oxygen. Oxygen is a gas. We know oxygen is present in our atmosphere. That is what we breathe in every day for respiration. Now, how can we test for this oxygen? We want to test that oxygen is present here. Yes, the oxygen in the atmosphere is not only oxygen that is present in air, but this oxygen in this place, we know is pure oxygen. So how do we test for it? We test for it by using what we call a splint. A splint that is glowing. A glowing splint. A splint that is glowing. You want to know something that glows? When you say something is glowing, look at somebody smoking cigarette, although I'm not advising you to go near somebody smoking cigarette, because you can enjoy yourself by sitting with that person. Just stay a little bit away from that person and look at that person. You see the cigarette becoming red at the other end from his mouth. That red thing is glowing. It's not bringing out flame, but it's glowing. So you get a splinter, or it's just a small stick. A splint is a small stick. Place it in. Make sure you place it in fire and it becomes glowing. Remove the flame. When it is glowing just like that cigarette, remove the test tube. Quickly cover the test tube and place at the mouth of the test tube. Remove your hand from the mouth of the test tube and place that glowing splint. What happens to the glowing splint? Boom! It starts, it relights, it brings out fire. So you say that yes, it is only oxygen that can cause a glowing splint to relight. It was glowing because the light was gone, so the flame was gone. Now to relight it, to rekindle it, to bring flame also in a glowing splint, only oxygen is the only gas that can do that. So if that occurs, that means the gas there is oxygen, and of course you will see that that will actually occur. So you see, it does what? You see, the gas inside here relights a glowing splint. Relight a glowing splint. You don't need so much to write here. Just say at the beginning, starting of the experiment, then later. Then the result is test for oxygen. You test for oxygen. So the result is that you test for oxygen. Test for oxygen from the gas collected from the collected gas, the gas collected at the bottom of the test tube is tested with a glowing splint. And what will be your observation? Observation will be that gas relights the glowing splint. And that shows your conclusion or inference. Conclusion is that gas is oxygen. Released gas is oxygen. So this is the test. Testing the gas. The gas collected at the bottom of the test tube is tested with a glowing splint. Observation: gas relights the glowing splint. So the conclusion is that released gas is oxygen. So this shows us that oxygen is released during photosynthesis. You can see, when you see this diagram, there was nothing here before. After some time, of course, in the presence of sunlight, you see a gas form there. So that gas is released as a result of photosynthesis. You can see the bubbles of gas coming out. So it's released as a result of photosynthesis. So you can see, you test the gas, test for oxygen. You want to test if it is actually oxygen, and it shows you that it is oxygen. It is oxygen. You can also connect the apparatus like this, and the oxygen will be collected here. We're going to use this apparatus later. Now, how do you show that sunlight is necessary for photosynthesis? We have seen how the evidence for photosynthesis is what? The presence of starch in the leaf of a photosynthetic leaf, a plant. Why the plant in the darkness there was no starch? That was our first experiment, the evidence for photosynthesis. Now we want to see how sunlight is important for photosynthesis. Again, we're going to use two leaves again. One, you pluck from a plant very early at dawn, before the sun rises. You pluck the leaf, then you come back to that same plant in the sun midday and pluck another leaf from the same plant. Of course, you are plucking plant from the same plant. So now the two plants and the two leaves, you then test them for the evidence of photosynthesis. What do you expect? From your knowledge of photosynthesis now, right now, you are thinking, I know. The leaf just coming from darkness, you plucked at dawn. Of course, photosynthesis occurred yesterday, during the day, the night came, then during the night, all the starch stored in the leaf released them by translocation to other parts of the plant where they are needed for respiration, and the leaf become discharged. Early in the morning, whatever leaf you pluck from the plant, or in dawn, not in the morning, at dawn, before the sun rises, you pluck the leaf, and what will you see? You will notice that there is high probability, there is high chance that there will be no starch in the leaf you have plucked. Of course, we know there will be no starch because the leaf has been discharged all throughout the night. So at dawn, before day breaks, we quickly pluck the leaf. Then two leaves now, one from the plant at dawn, a discharged leaf, and the other one during the day. In the midday, we pluck another leaf. Test the two leaves for starch, and this is the result you will see. This is the result you see at the start of the experiment. Both of them, two leaves I have. At the start of the experiment, I have these two leaves. At the beginning of the experiment, I have these two leaves. But before I test them for starch, I try to cover. I'm using something else now. Sorry. The leaf I just told you about, if I continue like that, let me quickly finish with that before I come to my diagram. If I continue like that, I'll find, if I test for starch, I'll find out that the leaf I'm bringing from the sun, will test positive for starch. It will turn blue-black. Why the leaf I'm bringing from the darkness will not turn blue-black? We just retain the color of iodine. That's one process. But the commonest process is this. Sorry. I get two leaves from the plant. I didn't use my diagram before. I just used a common knowledge. I get two leaves from the plant. The leaves are attached, still attached to the plant. Attached. At dawn, I went to the plant and I covered one part of the leaf like this, back and front. I cover one part with black paper and I cut any pattern. I'm cutting an L pattern here now. Here. Any pattern. I cut a pattern there on the leaf. Attached, the leaf is attached to the plant. The leaf is attached to the plant. I cut a pattern. I'm using one leaf, one leaf attached to the plant. I'm really sorry. Now, there are so many ways you can pass for this experiment. So this is attached leaf. Then I just use my black paper to cover the leaf front and back. And I cut a pattern there. Then I allow, I did that at dawn. Quickly went there. I quickly did that at dawn. At dawn, you can see little by little. So I quickly did that at dawn. Then I left my plant. At midday, or just after midday, I came back to my plant and I plucked that leaf. I plucked the leaf. I took the leaf like that to my lab. I took the leaf to my lab. I removed the black thing, the black paper, and I tested the leaf for starch. I tested the leaf for starch. I tested the leaf for starch, just like this. I added iodine solution. I added iodine solution to the leaf. I added iodine solution. I did all this to that leaf. Again, a particular leaf on a plant, I got the leaf at dawn and I cover the leaf and I make with a black paper or a black tape and I made a design there. The leaf is still attached to the plant. I left it like that. I made sure the leaf is in a position to get enough sunlight. Then I came back after midday, maybe at 1 o'clock in the 1 p.m. I plucked the leaf. Then I took it to my lab and I removed that cover. I removed that cover. So when I remove the cover, the leaf, everything will appear green. Everything will appear green. The leaf will appear everywhere green. When I remove that, everywhere will be green. Everywhere will be green when I remove that. The whole thing will be green. So I've removed the paper. I'm going to test for starch now. So everything will be green. After testing for starch, this reappears again. Everything was green when I removed that thing. I removed the paper because the paper was covering it. I removed. Then I took my leaf like this and tested for starch. Took the proof of photosynthesis. What did I see? I found out that at the end, the area that was not covered by the black paper turned blue-black. Look at this, blue-black, blue-black. All the areas uncovered turned blue-black. Even that thing I made. So there is no cover here. It's not a paper. This is iodine color. I see iodine color there. Orange color like that, or I see iodine color there. I see iodine color. So in those areas, are covered, the covered area took the color of iodine, and the areas exposed, you can see my L is showing now, the areas exposed to sunlight. Don't forget that place was exposed to sunlight. The L side was exposed to sunlight. It was exposed to sunlight because I covered the other part, and the covered area was not exposed to sunlight. So the covered area not exposed to sunlight, look at what happened to it. There was no starch. There is no starch in it. So you can write it. This is the real experiment. Perform the experiment with the leaf attached to the parent plant. Good. Cover both sides of the leaf with a strip of black paper, exposing a small area in the middle, the L part. Leave in strong sun for hours. Pluck the leaf and test it for starch. Only the area exposed to sunlight turn blue-black. Turn blue-black, showing sunlight is necessary for photosynthesis. Because when it turns blue-black, it shows that you have what inside? You have starch. And this is telling you that starch is important for photosynthesis. Sunlight is important for photosynthesis. You can see that. You have seen that oxygen is given out during photosynthesis, and you have now seen that sunlight is important for photosynthesis. Somebody will tell me, now, how do you show that carbon dioxide is important for photosynthesis? That is the next one we're going to look at. I will show that carbon dioxide is important for photosynthesis. I go to a plant. before sunrise, I know the starch as the plant has been discharged. No more starch in the leaves. I go to one of the leaves and I set up this apparatus. I have my conical flask and I have my rubber bung or my wooden cork, and I place a leaf, one of the leaf inside the conical flask already with caustic soda inside, caustic soda solution. Air is trapped inside and the leaf is trapped inside. So I trap the leaf in here. I make sure that some air inside here trapped also, but the air here inside here, because of the presence of caustic soda, the carbon dioxide in the air will be removed. The caustic soda will remove the carbon dioxide. That means the air I trapped in here, there is no carbon dioxide there. I have to make sure that new air will not enter. I seal the mouth of this apparatus with a petroleum jelly or Vaseline. I seal the mouth with petroleum jelly like this, so that I am sure that no air comes in. So I make it airtight. I use petroleum jelly or Vaseline there to seal petroleum jelly. To make sure that this is airtight, no new air enters. The air I trapped inside that is now devoid, that is not lacking carbon dioxide, that is the air there, is lacking carbon dioxide because of this caustic soda. The caustic soda removes the carbon dioxide. Then I leave it. I did this at dawn. I set it up. I go my own way. Go do my work. Go my own way. Then I return back after midday. Quickly detach that. I detached it. And I took the whole thing to my lab, took this to my lab. I detached it from the parent plant, took it to my lab and removed that leaf. I removed that leaf and test the leaf for starch as we have done before. What did I find out? The leaf test negative to starch, did not change to blue-black. And of course, I did the same thing with another leaf that was outside, that was not trapped. And that leaf outside, which is my control now, tested what? Positive for starch. This to test positive. Why is it not testing positive? What is the difference between this leaf outside and the leaf inside? The difference is that the leaf inside has no carbon dioxide because sodium hydroxide or caustic soda solution has removed the carbon dioxide in the air trapped here. But this guy is having free carbon dioxide from the atmosphere. The air is not trapped. So this guy I plucked from the free one, I got my starch. And this no starch, that means photosynthesis did not take place. Why didn't photosynthesis take place there in that trapped leaf? Because there is no what? There is no carbon dioxide. Write this down. Step 1. Trap a leaf on a tree in a conical flask with caustic soda solution. Make the flask airtight using petroleum jelly. Leave the leaf attached to the plant in the sun for some hours. Step 2. Detach the trapped leaf and any other free leaf from the same plant and test both leaves for starch. Write this down. Trapped leaf does not turn blue-black as it contains no starch because photosynthesis did not occur. Because photosynthesis did not occur. Because since carbon dioxide photosynthesis did not occur since carbon dioxide in the trapped air was absorbed by sodium hydroxide solution or caustic soda solution. On here, the free leaf turns blue-black as CO2, carbon dioxide, water, and sunlight was available for photosynthesis. Everything was available for the other one. So write this down. Draw this, and write this, and this. So students, this is where we will stop with our evidence today. One more evidence, which is, we can quickly do that before we stop. One more evidence to show that chlorophyll is needed for photosynthesis. That is quite easy. Go to a variegated, get a plant with variegated leaf. A variegated leaf is a leaf which contains green and patches of other color. So go to it. They are so common in your environment. It contains green part and patches of other color. These places where you have red now in my leaf, this is a variegated leaf before the experiment. This place where you have green, it has chlorophyll, and this area where it is colored, we have no chlorophyll there. You have no chlorophyll there. You have no chlorophyll there. So what happens? At midday, pluck both leaves. Please, I'm not going to give you a note on this, so you write this down yourself. Get a variegated leaf, a variegated leaf from actively photosynthesizing plant. That is a plant in the afternoon, hot afternoon, like after midday. Pluck the leaf. Take the leaf to your lab and test for starch. You know how to test for starch now. Go back. If you don't know, rewind your video and go back. You test for starch. When you test for starch, after the experiment, this is what you are going to see. The green part will change blue-black. That means starch is present in those areas because photosynthesis has occurred, glucose was formed, and immediately converted to what? Starch. In the areas the red area will remain, we have iodine color. The red area we have iodine color because starch is not present in those areas. They are going to retain iodine color. There we have iodine color. The red area we have iodine color. The red area we have iodine color. The red area we have iodine color because starch is not present in the red area. So it will take up the color of iodine. Yes, you took the leaf, you boil it to soften it, you decolorize it, all colors gone. All colors gone when you pluck it. Then you took it, you wash it again, and you added iodine solution. The area that was red before took the color of iodine, and the other area that was green before, the green area, now tested positive for starch, shows that starch is present. So that means only the green area. Photosynthesis only took place only in the green area because chlorophyll is present. Area without chlorophyll, no photosynthesis. So this shows you that for photosynthesis to occur here, chlorophyll is present is needed for photosynthesis. For photosynthesis not to occur in this area, that means chlorophyll is absent there. Because the only difference between those two areas is the presence of chlorophyll, absence of chlorophyll. So the presence of chlorophyll makes this area test positive for starch to show the evidence of photosynthesis, and the other area, no photosynthesis. Form your note on that. That is easy enough. So students, this is where I'm going to stop. My next class is going to be factors which affect the rate of photosynthesis. That will be my next class. Should you have any question on investigating photosynthesis, let me know, and I will be very glad. I'll be very glad to send you another video to clarify your doubt. Good day and God bless.